government has given us the task of identifying and ranking 4 sites of special scientific interest. We need to examine the biodiversity and biomass of each site, and we need to look at how they differ seasonally. So our hypothesis is that each site is in fact different than the other sites. Our null hypothesis is that the sites are in fact the same. Because the woody species are long-lived and slow-growing, we shouldn't see a change over just a short season. So our hypothesis is that the seasons are equal. Our null hypothesis is that they are different. We need to discuss the preliminary studies, the experimental design, and the methods we're going to use.
How about two preliminary studies? The first one is to determine the contrast size we use, and the second one is to estimate the optimal sample size we need. Therefore, we need to know the tree density by the preliminary A first. We can use the aeroscan laser system to get the digital surface data, and then use NASA's ATLAS to get the waveform image. Then we can apply the LM technique to determine the optimal quadrant size. For preliminary B, we can first study 5 quadrants per site and then get the data to calculate the mean and SD. Then we can compare site A, B, C, and D by the ANOVA, and then using the G-Power software to calculate the optimal sample size by using the statistical power to be 0.8. Then we can find a new edge for modifying our experimental design in the field. The optimum quadrant size will be 10 times 10 meter, and then the optimal sample size will be 10 quadrants per site.
With that information, we should be able to formulate a pretty good experimental design.
This will be our experimental design. We will be comparing 4 different sites in 2 different seasons. So since we only have 4 days to do this for each season, we're going to dedicate 1 day each site. And we will be doing this within 2 weeks during the peak times of the wet and dry season. So we will randomly select 10 quadrants using a random number table for each site.
Now we need to consider how we're actually going to do the surveys when we arrive on the site. We need to discuss biodiversity and biomass.
There are 2 ways of calculating biomass. One is by allometric method and the other is by linear regression equation. Considering the time limitation, we just move to the allometric method of calculating the total above ground biomass just by calculating the diameter and breast height of the tree. We use 2 measurements here to calculate the total biomass just by measuring the diameter of the breast height, which is above 1.3 meters from above ground level, and height of the tree. From this we just calculate the total biomass with species specific constants, and from this we sum up the biomass of all the trees per quadrant, which will be represented as kilogram per meter square.
I wonder, was there any problems when we went out to collect data?
Did we ever find out if those 2 species we identified were actually the same?
Yeah, I don't know about that, but I had a lot of trouble during that day because of the typhoon. So I could hardly see, and I don't know if I counted everything.
Besides, we didn't collect the data from the same day for different sites. So within that 2 weeks, maybe there are some little errors between.
We'll have to keep those in mind when we analyze the data. How about that data? Did we get a chance to graph it, Macarena?
Actually, we can see very interesting difference between the species richness and between the sites. But actually, during the seasons, there are no difference between the species richness and the season. Now, in the biomass, we can see something similar. There's difference between the sites, but there are no difference between the seasons. And in the abundance, we also see difference between the sites, and you can see that the B site is the lower abundance. We also calculated the Simpson index, so we can see that the biggest index is in the site C, followed by the B, and the last one is A.
It looks like we'll have to use the 2-tailed 2-sample t-test since we just have the wet and the dry season. And to analyze the difference between all 4 sites, we'll have to be using one-way ANOVA, which will tell us that there is a difference. But then we'll have to go further and use the 2-keys test to determine which ones are different and how they are grouped.
Well, from the Simpson's diversity index, site C seems to be more diverse. But when compared to the biomass, site D has more biomass.
Based on the result of t-test, it's found that there's no seasonal difference for the biomass and also biodiversity for all the 4 sites.
Okay, so let's write up that report. We'll send it in.